Hi there everyone, and welcome to this first Unit 2 lesson. Today we're going to revisit factors, multiples and primes, which we've touched on in a previous lesson. I'm Melissa Lieberman, I'm the in-house math teacher at ICS Learn and your teacher for today's online session. I work here full-time at ICS Learn, so you can contact me anytime using the details there on the screen if you want to ask me anything about these lessons, for example, or contact your tutor. So today we're going to revise prime factors and multiples. So we'll just revise what those are, and we'll also extend on this to look at how to find the highest common factor and the lowest common multiple of bigger numbers using what we call prime factor decomposition, or products of prime factors. I'm probably saying a lot of words there that maybe you don't remember what they mean, but we'll cover it all in the lesson. The lesson will last about 1 hour, and it will all be recorded. So if you're watching the recorded version, you can pause and watch it in several sections if you want. I've got lots of people watching live today, so if you want to say hi in the chat box there might be nothing in the chat box if you're watching the recording, but there's lots of people here, and they're all ready to chat and add to the lesson, so you don't feel like you're on your own if you're watching even the recording. So one thing I always say is always make sure that you write notes as you watch the lesson, because this will help you to sort of process the information, and it's also really good for revision later on, so you don't have to watch the lesson again. You can just use your written notes. So as you watch, if you write slowly, you can pause, obviously not if you're watching the live version, and keep a record, keep it somewhere neat and safe, and you can use that later on for revision. I'm not going to use a calculator too much in this lesson, but there is a kind of a method that I'm going to show you to find lowest common multiples using the calculator. So if you've got a calculator handy, that would be good. I don't have mine at the moment, but I've got one on my computer. Use your scientific calculator if you can, that way you get used to where everything is on it. But for today, we're not going to use any advanced functions, but a calculator might be handy. Now, if you haven't watched all of the Unit 1 lessons, let me just get my So I did introduce primes, factors and multiples in lesson 3. I also did square numbers and cube numbers and so on. So hopefully you remember that lesson. If you haven't watched it yet and you're just diving in and watching the first lesson, Unit 2, and you do want to go back and watch Unit 3 to revise those things, I'm going to go over them again today anyway. You can click here. Violet's just said hello there in the box, I've noticed. So if you're watching the WebEx version of this, you can just click in the chat box. So go up to the top of the page, click on view, click on chat, that will open up the chat box. Click on the link and it will just open up in your browser. If you're not watching the WebEx version, if you're watching this lesson on YouTube, then all of these links are pasted in the box underneath the video. So scroll down under the video, there's a description box that says show more in capital letters, click on that and a drop down menu will come down and the link will be there. So watch lesson 3 if you haven't already. Another thing to mention is that when you finished all of Unit 1, when you've watched all of the Unit 1 lessons, you should complete test paper 1. So you can either use that link in the study plan or go to your main GCSE Maths course page, scroll down to the very bottom of the page, and at the bottom of your Unit 1 materials, there's a link there, and if you click on that link, yours probably doesn't say tutors, but there's a screen grab from mine. Click on test paper 1, complete the test, you need 50% to pass. Send it to your tutor, so you can either handwrite it and just take a photo of each page or scan it, upload it, send it to your tutor. If you've got any problems, let me know. They'll mark it and then that will release your Unit 2 activities. So once you've done that Unit 1 test, you'll be able to see this first lesson here, which covers what I'm doing today, which is factors, multiples and primes. And then you'll just unlock the materials. I mean, if you don't do the Unit 1 test, you can still carry on by watching these lessons and using the notes in the textbook. The textbook covers everything, so you don't have to. If you want to put off doing the Unit 1 test, then you can. Okay, any questions about completing test paper 1? Probably repeat this every time anyway. If you want to read up on this, the material that I'm doing today, there's some more worked examples and explanation in your digital textbooks. It's chapter 4. I think this is both in the higher and the foundation tier books. I'm just going to link you now to the foundation tier ebook. So chapter 4, sections 2 and 3. There's some questions in there. I'm not going to do any real life context problems today, just the basic prime factor method for finding highest common factors and lowest common multiples. Not that mix them up, but you can use chapter 4 there. So we'll do some revision first. I think I briefly covered how to write numbers as products of prime factors, but I'll go into a bit more detail on that today, and then we'll look at some different methods for using these prime factors. It's sometimes called prime factor decomposition. Now, it's quite an interesting branch of number theory, but we'll look at that in a minute. Okay then, so a bit of revision first. Factors. It's easy to get factors and multiples mixed up, but factors, it might help to think of them as divisors. These are whole numbers that divide exactly into another number. So, ready on the chat box there? What are the factors of 10? So if I said to you, what are the factors of 10? What I'm asking you is, what are all of the whole numbers that divide into 10 exactly without leaving any remainders? So, quick as you can, just to have a little bit of competition. Type all of the factors of 10 into the chat box and we'll see who's the first person to get them all right and all correct. I don't mind what order they're in, and we'll see. So, oh, Beta, well done. And I think this is your first live webinar. 1, 2, 5, 10. And Jane, good. Yes, Debbie's got 2 and 5, but don't forget that 1 and 10 also divide exactly into 10. So every number has got 1 and the number itself, and then in any other numbers that multiply into it. So that's perfectly right, yeah. Often, when you're writing the factors of a number, they go in pairs. So I'll go through that today. So for example, if you think 1 times 10 is 10, so that's 1 and 10, and then 2 times 5 is 10, so you could have 2 and 5. So often they go in pairs, and that helps you make sure that you've not missed any out. So perfect, Summer, Debbie and Jane, perfect, good. So here's another example. Factors of 20 are 1, 2, 4, 5, 10, and 20. And you can think of them in pairs because we've got, let me just make that pen tool a little bit thinner. So we've got 1 times 20 is 20. And then 2 times 10 is 20, and 4 times 5 is 20. So they're all the numbers that divide into 20 exactly. Now, the highest common factor of 2 numbers, no, we can't have the highest common factor, we need to have at least 2 numbers, sometimes you can have more, is the highest number that divides exactly into both of the numbers. And you've probably met highest, the idea of highest common factor, when, for example, you're cancelling fractions. So when you're cancelling down a fraction, if you divide by the highest common factor of both the top and the bottom, that will cancel down the fraction quickly. You might also have met it in the idea of algebra. Sometimes we factorise an expression, which means we take out of some algebraic terms the biggest number that divides into both. So that's also an example of using factors. So it's something that we'll visit again and will be repeated throughout the course. So for example, supposing you were asked to find the highest common factor of 12 and 20. Sometimes it's called HCF or highest common factor. I think in the exams they would probably say highest common factor rather than the abbreviation. So what this is asking you is, what is the biggest number that divides into both 12 and 20? Now, sometimes you could probably just look at, because they're very small numbers and you kind of have a feel for what the factors are. So I know that 2 is a factor of both those numbers because they're both even numbers, but there's a bigger number that goes into both those numbers. So Summer, Beta, Violet, Jane, top of the class. There's more than just these 4 people watching, by the way, but I'm not going to name and shame anyone who's watching and not answering any of the questions. So the way we normally do it for small numbers is we list all the factors of both numbers. We've already found factors of 20 a minute ago. List all the factors of 12, list all the factors of 20, and then look for the biggest number on both those lists. You can kind of do it in your head. So the factors of 12 are here. 1, 2, 3, 4, 6, and 12. Those are all the numbers that divide exactly into 12 without leaving remainders, and the factors of 20 underneath. And then we just look at the list and we say, what's the biggest number on both lists? And it's 4. Now, some people get a bit mixed up with highest common factor and lowest common multiple, and I think that factors are normally smaller than both numbers, but we say highest common factor, so that sometimes makes you think that, oh, sorry, I was on holiday last week in the south of France, I got a mosquito bite. It's a bit itchy. Sorry about that. So highest common factor is the biggest number, but it's smaller than both numbers because it's the number that divides into it. So the highest common factor of 12 and 20 is 4. Then we have the lowest common multiple. So this is another thing that is often useful in many areas of maths, for example, fractions. Lowest common multiple is often used to find the lowest common denominator when we're adding and subtracting fractions. So that's probably something that you, even if you didn't know it was called that, you've been using quite a lot already. Now, a multiple, easier to work out by its name, is just any number that is in that numbers times table. So for example, multiples of 5 are 5, 10, 15, 20, gone forever, 500, 5 million, 555. Any number that can be divided exactly by 5. Any number that has 5 as a factor is a multiple of 5. So you can see how factors and multiples kind of go together. Here's examples of multiples of 7. So multiples of 7 are just numbers that are in the 7 times table. 7, 14, 21, 28. Could be 7 million or 777. Numbers that can be divided exactly by 7 without leaving remainder are multiples of 7. So that's how these numbers are connected. When we're talking about factors and multiples, we're always talking about whole numbers. We're not looking at fractions or decimals. This is just for whole numbers. Now, the lowest common multiple of two numbers is the smallest number that is a multiple of both numbers. So if you've got two small numbers, list the first few multiples. You might need to, depends on how small it is. List the first few multiples of each number and then look for the smallest number in both lists. I would usually start with a bigger number, write down the multiples until you reach one that is also a multiple of the other number. So if it's small numbers, we do it like this. So here's two quite small numbers, 8 and 12. So write down the first few multiples of each number. So write down numbers in the 8 times table, write down some numbers in the 12 times table until you get to one that is in both lists. You got it, 24. I mean, with these smaller numbers, you can probably work it out quite easily in your head. So just to be sure, multiples of 8, 16, 24, 32, 40, just to go through. And 12, we've got 12, 24, 36, 48, 60. 48, I think, is in both. No, it's not. Yeah, 48 is in both lists, but it's not the lowest one. 24. So if you said 24, very good. You probably watched the last lesson, because I think this is a repeat of the example I did in lesson 3. So 24 is the lowest number that both 8 and 12 divide exactly into without leaving remainder. So if I was trying to work out 1/8, just to put it in a kind of context that you've probably met before, if I was working out 1/8 plus 5/12, and I wanted to convert those into a fraction where the denominators were the same, I would convert them both into 24ths, because 24 is the lowest common multiple. So I would just change both of these. I'm not going to do the whole of this calculation. It's just to show you where you've probably met this idea before. And you would write both these fractions as equivalent fractions over 24. Once the denominators are the same, then you can add the tops together and work out the answer. You can do that now if you want. I'm not going to work it out. It's just to show you how this is used in other areas of maths. So that's our answer, 24. Well done if you got it very quickly. Now, prime numbers are very important in maths. Now, I know it sounds like, what's the point in prime numbers? Prime numbers are really, really important because people who work with number theory, with whole numbers, prime numbers are like the building blocks of all other numbers, because so we've got two types of whole numbers. We're talking about numbers that are greater than 0. So natural numbers, 1, 2, 3, 4, 5, 6, 7, whole numbers, come in two types. They're either prime numbers, which means they can only be divided by 1 in the number themselves, or they're what we call composite numbers. Composite numbers are kind of made up of prime numbers. In other words, you can multiply any other prime numbers together to get the composite number. So this is the idea that we're going to look at when we break numbers up into their prime factors. So if there's a prime number, it can't be broken up. If it's a composite number, it can be broken up into prime numbers. So it's very important that we know about prime numbers so we can break numbers up into their prime factors. This is called the fundamental theorem of arithmetic, as it was. I don't think it's that important anymore, but it probably has important applications. I'm not enough of a knowledgeable maths person to know what application it has, but there have been mathematicians in the past that have devoted their whole life into working with prime numbers. So they're pretty important if you like that kind of thing. So, example, write down the first 10 prime numbers. So, have a little think about it, type it in the box if you want to have a go. You need to learn these because it's when you're writing numbers as products of prime factors, you really should know all of the prime numbers so that you can use them to then write that out. So, if you're asked to write a number as a product of prime factors or the prime factor decomposition of a number, it would help to write down all of the prime numbers maybe the first 10. Don't worry about knowing them beyond that, but the first 10 certainly would be good. So, oh, very good, Beta. You're doing brilliantly today. So you think 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Yeah, good. Jane, I think, has gone a few better than that. 29, 31, 37. I don't think you've missed any out. Very, very, very good. And I'm very pleased to see that both people that have contributed so far, and Samuel, excellent, glad that you've learned those, have not put 1. It's a common mistake to say that 1 is a prime number, but I suppose it's the way that we define it. So a prime number is a number greater than 1. So in other words, it doesn't include 1. Sometimes they say a prime number is a number that has exactly 2 factors. So 1 doesn't count because it's only got 1 factor, which is 1 itself. So lots of theories, number theories, fall down if we allow 1 to be a prime number. So 1 is not a prime number. Let's see, Summer, if you're right, and Charlotte, let's have a look. So first 10 prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Don't make the mistake of thinking that because a number is odd that it's prime. So for example, 15 is an odd number, but it's not prime because it's divisible by 3 and 5. Sometimes you can have a number, so the only one actually is 2. So 2 is even. All prime numbers are odd except for 2, so they are odd numbers, but not all odd numbers are prime numbers. So perfect. And if you continue on, I think we've got 31. In fact, I've got a diagram here. I might have put 1 is not a prime number, 2 is the only even prime number, and except for 2 and 5, all prime numbers end in a 1, 3, 7, or 9. But some numbers look as if they're probably prime, but they're not. 91, for example, looks like a prime number, but it's not. I can't remember what it is. I think it's 3 times 17 or 7 times 13, something like that. Get those mixed up. So here's a diagram which shows you. So who was it that went above and beyond? So we've got I'll just check whether you were right. So we've got 31, 37, good. 31, 37. Taya, you've got 41, good. 43, 47, 53, 59, 61. Yeah, I think you win. We shall give Taya, have I said your name right? I think you win the prize, which I think you've got the first, I'm not going to count them, but you did very well. You've almost got all of the prime numbers that are on that list, so great. In practice, you probably will only need the first 6 or 7 for this work on writing numbers as prime factors. So when we talk about product of prime factors, remember that the word product, another word for you to learn, means numbers multiplied together. And I think a really nice way of writing numbers as products of prime factors is to use factor trees. And it's just a way of splitting the number up. But you don't have to use factor trees if you just want to break the number up in any other way. So starting with the number, remember it has to be a composite number because a prime number won't break down because it can only be multiplied by 1 in itself. You just think of any 2 numbers that multiply together to make that number and then keep breaking it down until you just get lots of prime numbers all multiplied together. One thing to note as well, this probably won't come up, but it's quite interesting, is that the prime factorization of each number is unique, so it will only give one answer. Maybe that's a little bit obvious because obviously they'll only multiply together to give us a specific number. So, for example, supposing we're asked to write the number 40 as a product of prime factors. Now, it's not a prime number, so it's a composite number. If it's a composite number, then it can be written as a product of prime factors. So I would look at 40 and I'd probably say, okay, well, 40 is 20 times 2. I could start breaking it up like this. It's just breaking the number up step by step. So Samuel, 2 times 2 times 2 times 5. Well, let's have a look at the method. So start by dividing. If it's an even number, I would start by saying, well, it's 2 times something. So 2 times 20. 2 is prime, so it can't be split up. But 20 is composite, so we can split that up. You don't need to know the word composite, but just to say that can be split up. And you could split it as 2 times 10, or you could split it as 4 times 5. It doesn't really matter, but let's do 2 times 10 like this. So 20 is 2 times 10. 2 can't be broken up, but the 10 can. And 10 is 2 times 5. And that way it keeps it all nice and neat, so we can just split it up step by step. When you've got all the numbers are prime, that's the answer. So the prime factorization of 40 is 2 times 2 times 2 times 5. Brilliant. Samuel. Jane, nearly there, but you need to put the multiplication symbol in. And Debbie, you're correct as well. So 2 times 2 times 2 times 5. And we can also write this in index notation just to save us having a big long chain of numbers. Remember that 2 times 2 times 2 can be written as 2 to the power of 3, or 2 cubed. That just means it's just a mathematical shorthand for 2 times 2 times 2. So it's just keeping things a bit neater. And then there's just 1 5 in there. So we just 2 to the power of 3, or 2 cubed times 5. So you can write it like that as well. And it might tell you in the exam, for example, write your answer in index form. So when it's talking about index form, it means this with a power in the answer. Okay, I'm sure you've had some practice of this already if you've done lesson 3. Another really nice method is a factor tree. So a factor tree, we put the number that we're splitting up at the top of the tree, and then you just think of any 2 numbers that multiply together to give that number. Have to be whole numbers, and you can't just do 1 and 40. You'll just end up going round in circles, so it has to not include the number itself. So we could, for example, say 5 times 8. The order doesn't really matter. If one of the numbers is prime, draw a circle around it because we can't split that up anymore. So I'll draw a circle around the 5. And then the 8, well, 8 is 2 times 4. So we just 2 more branches, that's why it's called a tree. 2 times 4. The 2 is prime, so put a circle around that. And then the 4 is 2 times 2. So we split it again there. You get exactly the same answer. And if you'd split it in a different way, if you'd done 2 and 10 at the top, sorry, not 2 and 10, 2 times 20, you would still get the same answer. So you just have to reorder it at the end. So if you and someone sitting next to you did the same question, you probably wouldn't get the exact same factor tree. So there's more than one way of doing a factor tree, especially for big numbers. And we've still got the same prime numbers at the end. 2 times 2 times 2 times 5. You normally write them in order. So it's actually the same answer as before. Okay, so if you're watching the recorded version of this, you might want to pause and try completing these factor trees yourself. But I'll go through the answers here. So if you're watching the live version and you want to just tell me what the prime factor decomposition is of each of these numbers, then you can try that. So here we've got 44. So they've given us the 2. So we need to sort of say, well, 2 times what? 2 times what equals? So we'll fill this in first. Equals 44. So 44 divided by 2, 22. So that missing number must be 22. So we'll put that in there. And then what 2 numbers multiply together to give us 22? Well, we can either put 2 times 11 or 11 times 2. It doesn't matter what way round they go. So we just fill those in like that. And that's our prime factor form for 44. 2 times 2 times 11. We just multiply together the numbers that have got a circle around them. Very good, Debbie, that's right. And Beta and Samuel, good. How about 72? Now 72 is more difficult because it's a number that's got lots of factors. So it's just going to take us a little bit longer. So 72, we've got 9 here already. And it doesn't matter if you split it up. You could do 2 times 36 or any number of ways. I think 12 times 8. No, not 12 times 8. Sorry, my times tables are rubbish. But I'm sure, no, 8 times 9, isn't it? And I'm sure 12 times 6? 12 times 6. I knew I'd get there eventually. So there's lots of numbers that multiply together to give 72. So it doesn't really matter which 2 numbers you start with. You always end up with the same numbers at the end. So if we've got a 9 here, you can either start by filling in these 2. So 9 is 3 times 3, so we could put those in. And then what number goes here? Well, what do we multiply 9 by to get 72? So that number there must be an 8. So we can fill that in there. Oops, I forgot to put the answer in there, so that's an 8. And then we've got the 3 times 3 under here. Now, the way the 8's been written, we've got something with a circle and something that doesn't have a circle. So the thing with the circle must be a prime number. That must be the 2 here and the 4 here. So 8 is 2 times 4, and then the 4 splits into 2 times 2. So these factor trees are a really nice way of working these out. I think there's examples in your textbook as well, so 2 times 2. So then when we write it all out, we've got, we usually put it in order. So we've got 2 times 2 times 2 times 3 times 3. And we can write that in index form as well because we've got lots of 2's and lots of 3's. Most of these examples will involve 2, 3, I nearly said 4, 4's not a prime number, 2, 3, 5, 7, maybe 11, but not much beyond that. So here we go. To write it in, we've got Violet, 3 to the power of 2 times 2 to the power of 3. Perfect, good. Normally you would do the 2 first just to keep them in order of size. So 2 cubed, 2 to the power of 3 times 3 squared. 3 to the power of 2. That's another way of writing the number 72. And if you're interested and you want to Google it online, there's lots of prime factorization calculators, because sometimes mathematicians need to work with very big numbers, and if they want to know the prime factor form for 1058, might take a long time to do a factor tree. So there's calculators that you can use. I think some calculators might even, I think I've got a button on my new calculator that will actually write the prime factorization form. It's quite a fancy calculator as in this way. So it's something that you do need to work out. Maybe not for GCSE so much, but it does come up. So here we're asked to find the highest common factor of 60 and 70. Now, if you want to, and you're asked this in the exam, you could just write down all of the factors of 60, all of the factors of 72, and just find the highest one. You can do that, but it's just because the numbers are quite big. 60 has got lots of factors, 72 has got lots of factors. It just might take a little bit longer. The more old-fashioned way of doing it is using products of prime factors, and that's the method that I'm going to show you today. So if these numbers were much bigger, if they were in the hundreds, then you probably would use products of prime factors to do it. So what you would do is you would first of all write 60 and 72 as products of prime factors. Now, we already wrote 72 as prime factors, but you just split it up in the usual way. So 60, 10 times 6, 10 is 2 times 5, circle those because they're prime numbers. 6 is 2 times 3, circle those because they're prime numbers. So we've got 60 there as products of prime factors. And some people are putting the answer, which is fine, but I think it's important. I just chose quite easy numbers because I wanted you to be comfortable with the method. Okay, so we've got 60 as product of prime factors. 72, here we just do 8 times 9, similar to the one that we did a minute ago. So we've got 2 there circled, 4 is 2 times 2, 9 is 3 times 3, so there's our prime factors. So first step, write the two numbers as a product of prime factors. The next step for finding the highest common factor is to circle the numbers that appear in both lists. So we've got 2 common to both lists, we've got another 2 common to both lists, and then we've got a 3 common to both lists. And those are the numbers that you multiply together to find the highest common factor. So both lists have got 2 times 2 times 3, which gives us 12, which people have correctly written there. Samuel and Jane and Taia, I hope I'm saying your name correctly, 12. So that's good. Highest common factor, quite easy. Lowest common multiple, bit more difficult. So use prime factors to find the lowest common multiple of 60 and 72. First step, write each number as a product of its prime factors. So we've done that already. Maybe this is a question that would have a part A, part B, part C, and we would have done that in a previous step. So first of all, write the numbers as products of prime factors. Now, depending on which textbooks you read, they'll give you lots of different ways of working this out, but the way I normally do it is for one of the numbers, so let's say 60, cross out the prime numbers that appear in both lists. In other words, what I'm crossing out is the highest common factor numbers. So I'm crossing out the 2 because I've got a 2 underneath, this 2 because I've got a 2 in here, and then this 3 because there's a 3 underneath. Then the lowest common multiple is the product of all the numbers that are left after you've crossed those ones out. So really, if you cross out the numbers that you had in the previous step, the ones that gave you the highest common factor, and you multiply together all the other numbers, that will give you the lowest common multiple. Perfect, Samuel. Very fast. Good. So in other words, 2 times 2 times 2 times 3 times 3 times 5, which gives you 72 times 5. And the reason I'm writing that 72 times 5 is because obviously all of these numbers here, 2 times 2 times 2 times 3 times 3, we know that those multiply together to give you 72. So rather than doing all that work again, I know that all these numbers here give me 72 because it's written above, and then I just times that by 5. So actually all I have to do is 72 times 5, and that will give me the answer, 360. Now these questions often appear on non-calculator papers, but I'm going to show you a method that you can use to work out the lowest common multiple, just because this is kind of tricky using a calculator, but you need a formula to do it. You don't really see this formula. I remember learning it when I was at university, and then nobody ever mentioned it when I was training to be a maths teacher, but it's a really handy formula, and that's this because I always forget the method of finding the lowest common multiple, and I remember it by remembering this relationship, and that is that the lowest common multiple of any two numbers, which is A and B are just the two numbers, is the product of A and B. So multiply A and B together, multiply the two numbers together, and then divide by the highest common factor. And that will give you the lowest common multiple. So you know that if you multiply two numbers together, that is going to be a common multiple, but it won't be the lowest one. Divide by the highest common factor, and that will give you the answer. The numbers will get quite big, but if you've got a calculator, no problem at all. Let's look at an example, the one that we just did. So if you wanted the lowest common multiple of 60 and 72, you would just try it now on your calculator. No, you'll get the same answer because we already worked it out. 60 times 72. You can press equals or just divide. And then we already worked out the highest common factor of 60 and 72 was 12. So we've got 4,320 divided by 12, 360. And that helps you to remember as well how to work it out, because what we're doing is we're multiplying the two numbers together and dividing by the highest common factor. So whatever way you do it is still going to work out as the same way as doing it any other way. Happy with that? Remember that, you don't need to learn it. I've not really seen it in any maths textbook, but I always think it's very handy. Okay, one more way. Venn diagrams you probably haven't met yet, but it's not a difficult idea, and we will do work on Venn diagrams later on when we do probability. I like this method. It's very visual. So we're still going to use the prime factor decomposition, and I'm going to use the same numbers again just to show you how the method works. But this time we're going to use a Venn diagram, and I think it's just a much nicer way of doing it. So first step, write the two numbers down as their prime factor form, which we've already worked out, prime factorization. Then we're going to do two overlapping circles. One circle will contain the prime factors of 60, and the other circle will contain the prime factors of 72. And then the overlap in the middle, we'll put the common prime factors, like this. So I'll give you a sec to draw that out. So in the pink circle, we're going to put these numbers, 2, 2, 3, and 5. And in the green circle, we're going to put these numbers, 2, 2, 2, 3, and 5. And in the bit in the middle, we're going to put the numbers that are in both lists. So it will work something like this. So there's a 2 in both of these here. So I'll put a 2 in here. And then I've got a 2 here and a 2 here. So I'll put that there. I've got 3 here and a 3 here. So I'll put the 3 here. So those are the numbers that are common to both of them, common to both numbers. So we put them in the overlap. And then you just fill in the rest of the circles with the other numbers. So in here, I'll do this neater in a minute. So in here we've got 2 times 2 times 3 times 5. Now 5 is not a factor of 72, so we're going to put the 5 out here. And then for the 72, we've got the 2, we've got 2, we've got another 2, so we've got a third 2, which is not a factor of 60, so we put that over here. And then we've got another 3. So I don't want that in the 60 circle, I want that over here. Okay, does that make sense? So altogether in the 60 circle, I've got 2, 2, 3, and 5. And the 72 circle, I've got 2, 2, 2, 3, 3. And in the overlap, I've got the ones that are factors of both. So kind of obviously, because we've done it this way, the highest common factor is given by the numbers that are in the overlap. Let's put those ones there. I've done those. 2 times 2 times 3, 12. We wrote that already. And then quite nicely, because we're not counting the highest common factor twice, if you think about it for a minute, you'll see why this works. So it's like taking the product of both numbers and then dividing by the highest common factor. Because it's these highest common factor numbers that we only want to count once rather than twice. So the lowest common multiple will be all of those numbers in the Venn diagram. 5 times 2 times 2 times 3 times 2 times 3. So we just multiply them all together, and we get 360 again. All right, so you can use that. Just whatever method you find easiest to remember. I'm going to show you another example. So here's one that we've not done already, but I'm not going to do the factor trees this time. We'll just write them down. So use a Venn diagram to find the highest common factor and lowest common multiple of 56 and 98. If you're watching the recorded version and you want to pause and try it yourself, you can. Those of you watching live will just have to be a bit quicker. So 56. If you want to do a factor tree, I'll probably just do 56. I always remember this because it's 7 times 8, and I always forget 7 times 8. And then that's a prime number, and I know that 8 is 2 times 2 times 2, but I'll just do it quickly here. 2, So if you need to just split that up very quickly, like this, and then 2 times 2. Do a little factor tree. And I'll let you work out the factor tree for 98 yourself. I'll probably start with 2 times 49, and then that'd be 2 times 49, 2 times 7 times 7, something like that. So there we go, perfect. 2 times 2 times 2 times 7 for 56, and for 98 is 2 times 7 times 7. So that's the prime factor form for those two numbers. Next step, we're going to do a Venn diagram. So 2 circles, 1 circle for 56. I don't even know if you can see my hands on the camera. 1 circle for 56, 1 circle for 98, and label them so you don't get them mixed up. You don't have to use colours unless you want to. And then the first step will be to fill in the section here in the middle with the numbers that are in both lists. So we've got 2 in both lists, so we'll put 2 in here. No, there's only 1 2 in 98, so we can't put any more 2s, but we do have a 7 in both lists as well. So in the overlap, we've got 2 and a 7. And then we just fill in the rest of the numbers. So 56, we've got 2, we've got 7. So we're just going to have 2 more 2s to fill in that circle to have all 4 of those prime factors all together. And then 98, got 2 and 7, we just need another 7. So we just put another 7 in there. So what is the highest common factor? Type in the chat box, please. So the highest common factor is the product of the numbers in the overlap. So in other words, multiply together the 2 numbers that you've got in the overlap. Brilliant. Samuel, Peter, Jane, Summer, perfect. 14, yes. So 14 is the highest number, the biggest number that divides into both 56 and 98. You might not have spotted that because if you don't know your 7 times table very well, you wouldn't necessarily know that 14 divided into 98. I wouldn't. If somebody said 98, would you know that 14 divided into exactly without leaving a remainder? I wouldn't. So with these higher numbers, you can see how it's helpful to write it in this prime factor form. So highest common factor, 2 times 7, 14. And then the lowest common multiple, we just multiply together all of the numbers in the diagram. So if you want to try that, you can. So it would just be 2 times 2 times 2, which is 8. You do it in a different order if you want, because now I'm going to have to work out 8 times 7, 56, and then 56 times 7. I'd probably do, if I was doing it, I'd probably be easier to do 7 times 7 is 49, double it, and double it again. So what is 49? Use a calculator. I think this might come up in non-calculator papers though. So 49 times 2 is 98. 98 times 4. Can you do that in your head? Maybe 4 times 200 and then take away 8. Brilliant, Debbie. I'm struggling here to try and work it out mentally. You probably have to do some kind of short multiplication though. 392. Let's see if you're right. Fantastic. Very good. 392. You can also use the method that I showed you earlier. So if you want to check it on your calculator, it would just be the 2 numbers multiplied together. Let's try it now to see if it works. 58 times 98. Oh, sorry, 56 that should be, shouldn't it? Sorry about that. So 56 times 98. Multiply them together. I'll just use the division line. Divided by 14. On your calculator, you can use 56 times 98, divide by 14, press equals, and it will give you 392. It's perfect. So that way you can check that answer. Make sure that you've done it right. So just get the time. Oh, we've got lots of time. We're doing well. Maybe finish a little bit earlier today. Here's a couple of exam-style questions. I'm just sticking to the mechanics of working these out. In your textbook, you'll have some actual real life, some examples that might be more wordy problems. But I'll let you work on those. And if you need any help, just contact me or your tutor. So, for part A, express 54 as a product of prime factors. So, if I saw this, all I'd think, oh, factor tree. So, factor tree. If you don't want to do a factor tree, you don't have to, but you would just put 54. Split it any way you want. So I know that 6 times 9 is 54, but you could also do 2 times 27, lots of other combinations, or is it divisible by 4? I don't know, 6 times 9, that'll do. Also 3 times, I don't know, my times tables are so bad, I can't even explain. I don't know how I managed to get a maths degree. There's actually no times tables in maths degrees. I will just put that out there. I just never remembered them. Okay, so 6 we split up like this, 2 times 3. And then 9 is 3 times 3, and we circle those because they're prime numbers. So the prime factor form of 54 is 2 times 3 times 3 times 3. You can just leave it like that. It doesn't say that you have to write it in index form, but if you want to show off, you can put it in the index form like this, 2 times 3 cubed. And that's worth 2 marks. Part B, find the lowest common multiple of 54 and 45. Almost read that backwards there, and the transpositions of each other. So to find the lowest common multiple, we need to find the, I mean, I suppose you don't have to, but I'm not going to, there's 2 ways of doing this, let's say. If you want to, and you can do it this way, you could start writing out multiples of 45. So 45, 90, add on 45 and do it that way, and then multiples of 54. That's probably a trickier way with such big numbers. So we're going to use the prime factor form, and the clue is in the first question, so that they've asked for the product of prime factors for 54. So let's write the product of prime factors for 45 and then use those numbers to find the lowest common multiple. So 45 is 5 times 9, 5 is prime, draw a circle around it, and 9 is 3 times 3. So 45 is 3 times 3 times 5. And 54, which we just worked out, is 2 times 3 times 3 times 3. Now I'm going to use the Venn diagram method because I quite like that. I think it's just easier to keep track of things. You could use the other method if you wanted to. The other method would be to say, right, I'm going to cross out the numbers that are in both lists and then multiply all the other numbers together. So you could use that method if you wanted to and just multiply all of those together. I think the Venn diagram, for me, because I sometimes forget, you know, it's just one of those things. I would prefer to use this method. So what we do is in the overlap, we want the prime numbers that are in both lists. So we've got a 3 here and a 3 here. So we put the 3 in there. We've got a 3 here and a 3 here. So we put that 3 in there. And those are the only 2 numbers that are common to both. And then we've got a 5 in this one, so we put that 5 in there. So altogether in that circle representing 45, we should have 3 numbers, 3, 3, 5. Good. 54. We've got the 2 3s we've written down already, and then we've got the 2 at the beginning, and then another 3, like that. And then the lowest common multiple is just all of those red numbers all multiplied together. And Samuel 270, Jane 270, Debbie 270, perfect. And if you've got a calculator, you can also check it. 45 times 54 divided by 9, which is the highest common factor of those numbers. And that will also give you the answer. It doesn't actually ask us for the highest common factor in this question, but you can work it out because it's the 3 times 3, which isn't common to both numbers. So fill all of those in, multiply all of those together, 2 times 3 times 3 times 3, did I say enough 3s, times 5, which is just taking a shortcut. So I'm saying 10 because I know if there's a 2 and a 5, then I'm going to multiply those together straight away to get 10. And then 3 times 3 times 3 is 27, 10 times 27, 270. Always look for shortcuts because if you've not got, if this is a non-calculator paper, you've got to multiply all those numbers together. Try and do it in the easiest way possible. Summer, fantastic, and Debbie. So everyone that says 270 is right. Okay, just a little bit of practice. One more. This time we're just being asked to write 504 as a product of prime factors. No lowest common multiples or highest common factors. Just it's quite a big number. Now this might take a little bit more work, is all. If it's a very big number, the first thing to do is say to yourself, is it an even number? If it's an even number, then just start with 2 times something. So to start with 2 times something, we need to say 504 divided by 2. Well, 500 divided by 2 is 250, and 4 divided by 2 is 2. So 252. So 2 times 252, let's start with that. And we know that 2 is a prime number, so we circle that. And then we just keep going. So as long as the numbers are even, we can do 2 times that number. So 252 is 2 times 126. I didn't just work that out, I just revealed it and pretended that I knew that that was that. Circle the 2, split the 126. 126, again, it's an even number, so we'll just divide that by 2. 2 times 63. Now 63 ends in 3, so it's not divisible by 2, but 6 and 3 are both multiples of 3, so we can just divide this by 3. 63 is 3 times 21. So we put 3 times 21 and we circle the 3. Doesn't matter what order we put them in. And then 21 is you do need to know your times tables for these, don't you? So 21 is 3 times 7. So they're both prime numbers, so we circle them. Let's have a look. That's supposed to be, yes, that's a 5. I think it's just bad handwriting. Yeah, that's a 2, 5, 2. Yeah, 2, 5, 2. I think I didn't write this. So someone I took this from the sample assessment materials, and these are the written solutions from Just Math. So yeah, that's the 2, 2, 5, 2. Okay, so once we've got our all our prime factors circled, we can just write them out in order of size. So we would write this as 2 times 2 times 2 times 3 times 3 times 7. And if you want to tidy that up to write them in index form, you can. So 2 times 2 times 2 is 2 to the power of 3. That's a mistake. That should be 2 squared, 3 squared, so that should be a 2 there. So 2 to the power of 3 times 3 to the power of 2. Let me just neaten that up and correct that. So that should be a 2, 3 to the power of 2 times 7. Okay, happy with that? 2 times 2 times 2 times 3. You could write it like that as well and you would still get full marks, and that's worth 3 marks altogether. It's quite an easy 3-mark question. So that's it. I'm going to give you some links to some YouTube videos. These are from Hegarty Maths. So if you want some more examples of doing factor trees, prime numbers, and prime factor decomposition, and also how to use prime factor decomposition to find lowest common multiples and highest common factors, I was going to paste them all in there. So remember, if you're watching the WebEx version of this, as long as your chat box is open, you should be able to just click on those links directly and they should open up in Hegarty Maths. Sometimes you need to log in, so log in first. If you haven't made an account with them yet, you can register there, and they've got loads of really good videos. Be aware that these GCSE revision videos are from the old style GCSE papers, so they might be a bit easier than the new 91 papers, but they're still very helpful. So if you want more practice of any of these, then you can watch those videos. There's some practice questions on your page, but of course, as I mentioned, you'll need to complete the test paper 2 first before you can do those. I'll just give you a link to that. So once you've completed test paper 1, you'll be able to work through these activities. I'll just give you a link to those, so in case you don't want to go, just click on it and it will open up straight away. You can answer the questions in the book. You know where the answers are. They're underneath where you download the book. So whether you're doing higher book or foundation book, it will be chapter 4, sections 2 and 3. You can use the foundation or the higher book. What page are the answers? The answers aren't in the textbook. The answers are, if you want a direct link to the answer book, I can give it to you now. So what I'm doing now, I won't show my desktop because it takes a little while to set it up. So I'm just going to my ICS Learn dashboard page. I'm going to the GCSE 91 Maths course. Here it is. In fact, I might show you this now. I'm just going to share my desktop with you just so I can show you where these are if you don't have them already. So the screen is just going to flash briefly while I share my desktop. Give it a second. So I only am enrolled in maths courses, so that's why it looks like this. So this is my page. So they go to this page here. Your page might look a little bit different. Scroll down until you see student course resources. This is where you download the textbook. Your view might look a little bit different from mine, but I don't know. I've got 2 links there now, but the answers are here. So to download the student book answers for the foundation book, click there. And to download the higher tier answers, click here. So if you want the foundation tier book answers, click here. I'll give you that link actually. Let me just copy that and put it into the chat box. So I'll just paste that in the chat box there. So I'll give you the foundation tier answers. And when you scroll down, if you want the answers to chapter 4, you can just click there where it says chapter 4. That'll take you straight to the chapter 4 answers. And here you can see 4A, exercise 4A, exercise 4B, exercise 4C. I can tell just by looking on those. I'm just going to zoom in a little bit, that these are probably asking me for prime factor forms of things because that's what those numbers look like. And I've got some quite tricky ones in there. And exercise 4D. And if you want to do the chapter review, that will give you a mixture of questions there at the end. So that's the answers. Is that okay? Let me just stop showing my desktop. While I'm here, actually, let me just go back to the GCSE Maths page. So I just want to make sure that when you get to the end of Unit 1, you know where to download the test. You just scroll down. That's the test paper, and then once you've completed that test paper and you've had some feedback from your tutor, you'll be able to do these factors, multiples, and primes questions. They just look like this, and you can go through. There's some videos in there, so I go through the same methods of using Venn diagrams and so on in these videos, and then you just type the answers in there. If you're not sure what the answers are for any of these, you can just scroll down to the very bottom of the page and reveal the answers. So if you want to, you can do that as well. So there's more videos in there for you, just to review those methods. Okay, stop sharing my desktop. There we go. Okay, that's about it for today. If you're using this book, or didn't bring it with me, if the textbook is a little bit difficult for you, there's a very good workbook which is by CGP, but we don't supply it. You would have to order it. Why is that not working? I'll give you a link. It's only about £5. You can maybe get it cheaper if you buy it secondhand. So if you want just more practice questions for foundation tier, even if you're doing higher tier, the advantage with this foundation tier version is that you can write the answers in the boxes, and this will cover everything up to grade 5, which is a lower grade B. If you want the higher tier book, you can get that as well, but it doesn't have spaces to write in the answers. So that's why I quite like this one. And that's just pages 8 and 9. We'll have some practice questions for you there. Maths Genie is an excellent revision website. So this Unit 2 is focusing more on grade 4 topics. So a lot of the topics I'll do here will be in the grade 4 section on Maths Genie. Go down to the bit that says lowest common multiple, highest common factor and lowest common multiple. This is a revision video. Watch the video. Click there to download exam style questions, and then click there to download solutions to those. So go to Maths Genie using the link, which I am about. I thought I'd put it in. I give it every lesson anyway, so this is Maths Genie. The key to being good at maths and you know, really mastering every topic is just as much practice as you can. I mean, I don't want you to spend too long on any one area, but the more practice questions you can do, then the better you'll understand the topic. So that's why I give you lots and lots of practice questions at the end. You don't have to do all of them. It's just suggestions, so that if you want to do a revision later on, you can also use these. So there's Maths Genie. Lots of you have bought Maths Buster, so if you've got a copy of that, if you want to just look at a demo version, I'm not sure if any lowest common multiple and highest common factor questions are in the demo version, but you can have a look at the demo. It's really good. It's got revision videos. I think you've got unlimited access to it. I've had mine for a few years anyway. So it's got videos. It's got thousands and thousands of practice questions. You just type in the box, it tells you straight away if you're right or wrong, and it's also got revision notes. So everything, CGP revision guides are really well known, so it's got all of the notes that's in there that are in their CGP revision guides as well, and loads and loads and loads of worked examples. Go into, so if you're using this and you've got this is from the foundation version, go to browse revision topics, scroll down to factors, multiples and primes, and then do these ones section 20. And also maybe 19, lowest common multiple and highest common factor, and then prime numbers and prime factors, which will be all about using the prime factor form to work those out. Okay, that's about it from me for today. Next lesson, I will cover the very important topic of rounding and approximation. So we'll do that next time on Thursday if you're watching the live lessons. This is just a screen grab from the study plan, so if you want the study plan, it's at the top of the GCSE 9-1 maths lessons, and all of these are hyperlinks if you want to watch the YouTube videos of any of the lessons. Tanisha, great that you've enjoyed the live lesson. If you want to leave me feedback, if you've enjoyed it, I'll give you a link to Trustpilot. Really appreciate if you would take a few seconds to leave me some feedback. I'll just give you a link here. Mention my name. That's always good. So click on that link there. Doesn't have to be an essay, just a few words say that you've enjoyed the live lesson. That'd be much appreciated. And thank you so much for coming. And I hope you can come to some future ones, and maybe I'll see you next lesson. Thank you. Bye-bye. Thanks, Jane. It's good. I'm glad it was good. So it's all recorded. If you want to watch it again, the link should go live just shortly after this session is finished. And I'll see you soon. Bye-bye. Thanks, Sam. Oh, is it Sam or Samuel? Thanks.